Today we are going to see the classification models like naive Bayes, logistic regression and clustering for building POS tagging and NER tools. So, in natural language processing, POS tagging and NER are fundamental tasks for any NLP pipeline. So, POS, as we already seen, it is a task which assigns the part of speech to each of the word in a sentence, and NER identifies the names, locations, organizations from the given text. And these tools will help us in giving some kind of linguistic insights so that the model performance in the later stage, especially in the downstream application, it will help us in improving the model efficiency. And not only that, it also important to have some kind of feature extraction before going into any machine learning technique. So, POS and NER are the two important tools which helps us in getting those feature extraction. So, it will help us in different kind of tasks. So, let us talk about why do we go for the classification models for building the POS tagging. So, classification models are essential, especially when we are predicting some kind of classes from the given input. So, right now the input for us, let us say POS tagging and named entities. So, we can handle different kind of variety of features like word frequency, contextual information and orthographic information or features from the given text need to be identified, not only the word and the tag, right. So, the classification model helps us in giving the probabilistic outputs, so that can be interpreted and analyzed at the later stage. And it is also helping us giving some kind of flexibility, so that some of the features that are important to predict the particular word and its tag can also be identified. For example, the particular word might end with a particular suffix and it occurs with a particular word in the preposition or a postposition. So, these informations will be relevant for us to identify the categories, and it can be used in both a supervised and semi-supervised learning settings. And of course, as we said, it is important for most of the NLP applications, and when we are working with across domains, these tools will help us in building the particular domain specific algorithms and models in a more efficient way. Okay. There are multiple classification models for doing POS and NER task. In this section, we are going to see three important things. One is naive Bayes. It's a very simple probabilistic model and it assumes independence between features and often used for POS tagging and NER kind of task. And another classification model is logistic regression. It is a discriminative model. So, it predicts the probability of POS tags and again their named entity, and it's not only useful for binary classification, like sentiment analysis or some other opinion identification, but it's also extendedly used for multi-class classification, especially in the POS tag and named entity context. And clustering is another classification model where words are being grouped based on the feature similarity, and it can be used for again unsupervised context, not only supervised context, and one of the example is k-means. So, we will see in detail. Let us start with naive Bayes. Naive Bayes is a simple and also powerful probabilistic classification algorithm. So, it is based on Bayes theorem. This theorem says that the probability of a class is being identified from the given set of features. So, it assumes that each feature that are contributed independently to the probability of the particular class. So, that it's a kind of very naive assumption. So, the key characteristics in naive Bayes is it is a probabilistic model because it uses the probability to predict the class of either new or unseen data. And also independence assumption is another important thing. Here the presence of a feature does not need to affect the presence and the absence of another class. And it's also very simple and fast, effective for the large data sets with the highest different kind of dimensionality. So, especially for text data, naive Bayes is being used more effectively. and it works in a limited computational resource. We don't need a big GPUs to run the naive Bayes. Limited data set and computational resources, we can easily build the naive Bayes algorithm. Okay, so what exactly it does? When we have a lot of data where the data is being classified into multiple classes, so the naive Bayes classifier identifies them into different classes. So it uses the likelihood. So for example, in that given document, how many of that different category is being identified as a probability, and prior probability of that particular category is identified, and within the given probability of the complete document. So it uses 3 probabilities. One is the probability, the likelihood probability of the document with that category, and the probability of that particular category, and the probability of document. So this is being identified with this algorithm formula to build the classification. Okay, as I just told, the Bayes theorem is nothing but the probability of x in the given context of y is nothing but the probability of y in the context of x, and the probability of y divided by the probability of x. Now this y is the target class. It can be a pure stag or a NER category, and x is an observed feature. It can be a word or a context, and the assumption here is features are conditionally independent given the class. So now it is very simple, very efficient. Now it works with a very sparse data, especially in the text classification. When we have very sparse data, it can be used as one of the baseline model when we are building any of the POS or NER kind of thing. And there is also a good balance, because this naive Bayes will be good for better performance, and interpretability is very high. Now, how it actually works? Let's start step by step. Now, given a word, we have to predict its POS by calculating how many times that the probability of that particular word occurs with that tag, right? Or probability of this particular tag given the particular word. Now, we have to also use prior probabilities, like probability of that tag, and also likelihood. That means how many times this particular word occurs with this tag. Now, it assumes that the occurrence of each word is independent of each other. Again, the independency is one of the key features in naive Bayes. And here, for example, when we have a training data, we have to build the probabilistic nature of this training data, and it is useful for when we are working with very unseen data. For example, in the POS context, if we want to predict the probability of verb with the given word run, we have to identify this probability using the likelihood probability of how many times the run occurred with the tag called VB, and what is the prior probability of VB, and what is the probability of the complete probability of the word run. So this will give us the probability of VB with the word run. Okay. Similarly, in NER context, it predicts the entity. It's like person, location kind of feature. And for example, if we want to predict London as a location, now what we have to do? We have a limited data set, let's say, and we have to identify this one in a multi-class classification stage. Now, the formula here is, now the probability of location with the word London is calculated by as per the find out the likelihood probability and find out the location probability and find out the London probability and calculate it. So, it will give us the probability of London, the location with the word London. So, now other than this complete word probability, can we again extract some kind of features when we are building the POS and NER? Yes, it is possible, because sometimes the word, their shape, their suffix and the other word that is coming along with that particular word are all being used as the feature to predict the given word's tag. Now, so it helps us in reducing the dimensionality. because other than like the information that are required can be eliminated, so that the very prevalent information will be captured. Now this is the feature selection is one of the important feature, because it helps on like focusing on the most important feature, and it also reduces the noise. So for example, some of the irrelevant words in the context do not contribute to Pure's and NER prediction, right? And also it prevents overfitting, because the risk that the model has to memorize everything, right, generalize everything, is a difficult thing. Instead, a feature selection will give us to give a focus on what kind of features need to be given focus, so that a particular word will be identified with the tag. And also it increases the efficiency, so that the faster training as well as testing will happen in a more effective way. And of course, in the context of pure tagging and NER, the relevant feature selections are prefix of a word, suffix of a word, capitalization, and other neighboring words. These are the 4 important relevant features that are being used when we are doing the pure tagging and NER. And again, naive Bayes has different varieties of naive Bayes. One of the naive Bayes which is very commonly being used for pure tagging and NER are multinomial naive Bayes. So what is this multinomial naive Bayes? It is a variant again used for discrete and count based data. Especially for count based data, multinomial naive Bayes is the most effective one. So when we can identify the frequencies, especially word frequencies and occurrences, then we can use the multinomial naive Bayes here. So here it assumes that feature vectors represents the counts of occurrences. That means we are trying to identify the word counts in the document. The key characteristics of naive Bayes or multinomial naive Bayes is it uses discrete features, especially the categorical features which are very much suitable to identify the purest informations, like the word frequencies. That means how many times the particular word with that particular tag is being identified, what is the frequency of it, not only the frequency of the word alone or the tag alone. Okay, so it is always about this categorical data, that means word frequencies, not the continuous features. So it uses the feature independence, that means each word's occurrence is independent of others given the class. So it's commonly used in NLP, not only in pure tagging and NER kind of context. So context like spam filtering, text categorization, sentiment analysis, we still use the multinomial naive Bayes. So the formula here is, as you could see, the difference between the naive Bayes and multinomial naive Bayes. The multinomial naive Bayes identifies, let's say the feature, let's say that is a category for us, and Y is the class label. Is using some kind of product of, it's a continuous product of the probability of the word, the first particular category, and given that particular label, and it is continuously being identified as a frequency. Okay, so that means where here x of I is the count of the feature, that is I, and Y is the class label. So it is different from naive Bayes in terms of discrete feature it uses and the frequency it uses to calculate. Now let's go into the next classification model, that's called logistic regression. And logistic regression is also one type of classification model where it predicts the probabilities for either binary or multi-class classification. So it uses the logistic function. The formula here is explained here, and here this logistic function either provides binary information, either yes or no or 0 or 1. So it provides the linear decision boundary for the classification task. So it can handle both binary as well as multi-class problems. And here regularization is the most important thing. So there are multiple regularization, it encourages the sparsity, and also it prevents the overfitting by penalizing large coefficients. So again, it is an interpretable model where coefficients beta of I It provides insights into the future importance. So now, how this logistical regression works? The model learns weights of the beta for each of the given feature, let's say x. It predicts the tag with the highest probability again, and it actually captures the linear relationship between the feature and the target variable. It is suitable for the task where the interpretability is important. It can be extended to other, like interaction terms where there are a lot of interaction between some other features. And it is effective especially with a large number of features like text processing task. For example, in POS context, if you are giving a word like book, now the features here is context word, POS tags of the surrounding words. And the model output is it predicts the POS tag with the highest probability, and it creates some kind of sigma kind of representation for the word and trying to identify the kind of weightage between the given tag with the given word. So, similarly to the POS tagger, NER is also heavily kind of benefited from the logistic regression kind of classification model. So, it predicts and uses the features like capitalization, word shape, position of the sentence kind of thing. And it can be used for multi-class classification. So, for example, person, location, organization kind of thing, and it handles the large feature spaces effectively with regularization. And again, for the domain specific features also can be integrated into this particular context. Okay. And the third classification model is clustering. So, there are multiple clustering techniques that are being available. So, I am going to talk only about one of the techniques. So, again it is used as an unsupervised learning technique where you are grouping similar data points into one place and trying to see this is a noun, this is a verb, this is a other category type. So, it is a process of arranging a group of objects in a manner that all the objects are belonging to a particular group or a particular cluster. Okay. This is not actually more similar to each other than to the objects in any other group. For example, when you have a raw data where let's say a lot of fruits, strawberries, apples and pear, now the algorithm helps us in identifying the apples and pear and the strawberries in a different way. So, we try to cluster them and try to give the tag associated with that. Now, how does this k-means clustering works? So, it works based on some kind of centroid based algorithm where the user must define the required number of cluster it wants to create. So, if we want to create let's say 10 POS tags, we have to actually define them what are those clusters, and we have to initialize the k cluster centroids. Initially starts with a centroid and we are trying to give some kind of points to the nearest centroid, and we have to recompute the centroid based on the current assignment. And we are trying to iterate this process until centroids are no longer going to change. So, now the sensitivity here is the initial choice of the k and the centroid. So, it is commonly used especially in POS and NER task, especially we are trying to cluster the words into POS categories and cluster the entities in NER task. So, to show how this actually works, the first iteration we are trying to find out the clusters with let's say there are 3 groups that we have to make from this particular data point, and we are trying to centralize let's say green with the particular place and red with another place and blue with another place, and we are trying to iterate and iterate. Let's say there are multiple iteration, in the final iteration there are no more changes later, then we are converging everything and finally the k-means clustering technique here. This is actually been applied for POS tagging. As we said, we are trying to group words with similar context into clusters, and it helps in unsupervised POS tagging, especially in the low resource setting when we have a very less data with an unannotated data set. This k clustering would be a very effective way of building the POS tagging. and it can also reveal some kind of hidden syntactic structure in a corpus. And it is useful for pre-processing step before applying into supervised model. And it helps also in identifying new pure stacks when we are evolving with new languages and new domain. This clustering method would be a best method for us. And it can be combined with other models for semi-supervised training. So similarly, similar to pure stacking, NER will also again get benefited from the clustering thing. So it groups similar entities based on features like embeddings. For example, clustering London, Paris and New York as locations is our aim. Now, this can be clustered through some kind of features like the capitalization and the place it's being used in a particular syntactic environment are being used before cluster them as location. And they are useful for domain specific entity discovery also. It enables unsupervised NER in the absence of labeled data. And it helps us in identifying new NER labels also when we want to identify the entities. And it provides insights into entity relationship and also the hierarchies. So now we have seen 3 classification methods, similarly like naive Bayes, a logistic regression and k-means using kind of clustering method. And how are we going to evaluate it? This evaluation is now no more than different from the statistical method. So again here we use accuracy. So accuracy, as we know, we are trying to identify the total predictions, from the total prediction identify the correct prediction. And precision is already been discussed. We are trying to identify the true positives of all the positive prediction. So for example, when you have like true positive and false positives, identify the true positives and calculate the precision. And similarly, recall is identifies the true positives from all the actual positives. So the recall is identified as like the true positives plus false negatives, under which true positives are being identified. And F1 score is a harmonic mean between the precision and recall. So it balances both the metric, because when we have an imbalanced data set, so F1 score will give us a harmonic mean of both precision and recall. So F1 score is identified as, let's say, 2 into precision into recall divided by precision plus recall. And these classification models are quite often being used in other NLP tasks also. For example, in other text classifications like sentiment analysis, topic categorization, spam detection kind of places, and speech recognition, where we are predicting the phonemes and mapping the speech into the text. And in machine translation, language model predictions are being used with the classification model, and word alignment also uses certain classification model. And in information retrieval kind of places, document ranking, query classifications can also be done by using this classification model. So the summary of this particular thing is classification models are crucial, especially even if you want to work on POs and NER with a limited computational resources and with a limited data set, we can still go for the classification models. So naive Bayes and logistic regressions offer a balance between simplicity and performance, and clustering helps in discovering the patterns in unlabeled data set. Of course, evaluation metrics are more or the same. Either it is a statistical or a classification method. It helps us in getting the effectiveness. So these models are not only used for POs and NER, it can be also adaptable to any other NLP task because of their versatility. Now, understanding these models are fundamental because it helps us in go for the understand the advanced NLP applications in the machine learning context. And another important thing is future engineering and model selection is the most important key success for any NLP project. So these classification models in a one way helps us in building the modules, which helps as a kind of pre-processing tool when we are going for any bigger applications. Thank you. Now let's see the code demo on how to use naive Bayes in a Python environment. So now we are using the reference from this particular link where you can also go and have a look and we are going to use it for the classroom purpose. So to use the naïve base for the POS kind of context, first thing we have to have importing the data sets and libraries. Now right now we are going to use NLTK, this natural language toolkit, as our data set point, and also we are importing some of the libraries for the data identification and data manipulation at the later stage. So let us load the data set. So the data set are nothing but we are downloading the tree bank from the corpus from the NLTK, and we are also downloading the universal tag set, which I already seen from the NLTK. And now we are reading the tree bank tagged sentences and putting it in the variable called NLTK data. Now if you could also see, when you are printing it, you could see the NLTK, from the NLTK data, the first two sentences along with the tags are being given here. Let's say if you want to print the sample set in the respective tag in an iteration, we are giving it in a tuple format. You see there are Perry Winken, 61 years old, will join the board. In this data set, there is no difference between proper noun and noun. So both are clubbed together as noun. So as you could see, this kind of information. Now, naïve base again requires a vectorization. We have to convert this data set into vectors, and we have to also split the data into train and the test data. So now again we are using the function where we are transforming the documents into the counter vectors. So we are using the count vectorizer from the sklearn library, and we are also using some kind of encoding libraries so that we are using it with the data as with the vectorization. So now we are storing the feature matrix and the response matrix in this particular data, and we are pulling the data into vectors. Okay. Now after we are getting that count vectors and also label encoders as vectors from the data set, we are splitting them into X and Y as training and the testing data set. It's a random split, we are doing it. Now once we are splitting them into the random split, now we are going to train the text and test the model. Let me just run this one. Now the training will take little bit of time, so we are using multinomial naïve base, which we have just discussed. So this multinomial naïve base takes this training and data sets from the NLTK library, NLTK data set, and let's just run the thing. And for testing, it's again predicting and putting it in the variable called yPredict, and it converts the text into its original format, because right now every output in the vectorization format, right? So now finally we are also predicting the labels also and converting it into the original label format. Now you could see it learns the matrix, and finally we are calculating this one and we are testing it with the. So now you could see the precision, recall and FN score from the matrix, that is again coming from sklearn. So we are identifying that one using the matrix called accuracy, and also classification report, something like precision, recall and FN score. You could see the accuracy of this naïve base on NLTK data set is 66.85, and the precision and recall and FN score are given here for the classification report, like 0, 1, 2, 3 are actually one of the tags that are being used here. Okay, so now let's go to the code demo on how to use linear regression and k nearest neighbors or KNN kind of clustering into the building of POS tagging. And similar to the naïve base, again we are using the NLTK dataset and other libraries. So now we are downloading the tree bank and the universal tag set. And second important thing in the linear regression, we can again use lot of features and we can convert the data into the required training format. So what we are doing is we are loading the tree bank with the universal tag set, and we are trying to extract the functions, especially features from the sentence. The features are like the feature of the word itself, or a prefix, or a suffix, or a capitalization, or position in the sentence. So we are creating a dictionary of all these features in one place. So for example, all these things are features that we are trying to extract from the sentences. This is the word itself, whereas this is a Boolean, true if this is the first word in the sentence, and this is true if it is the last word in the sentence. So, we are identifying them using these features, and we are also identifying whether it is the first letter or all letters in the capital or all letters in the lowercase, and we are also identifying the prefix, that means the first character of the word, that is the first character is a prefix, and second character of the word, third character of the word. Similarly, from the other side, suffix, that means last character of the word and last 2 characters and last 3 characters. And these are the feature information that have been extracted from a given word. And not only that, the previous word and the next word is also been identified. If the previous word, let's say if it is a null, that means it is the sentence starting position, right? So, that's also been identified. And next word, in case if the next word is no word, that means end of the sentence, that's also been identified. And similarly, if the word consists any numerical digit, that's also been identified. And is there any capital letter within the word, that is called camel capitalization. So, camel capitalization is also been identified. So, finally, we are returning the feature. So, now we are creating a function where from the tagged sentences, we are trying to actually already extracting the feature, and we are trying to get that label, and now each sentence is processed word by word, so that we are extracting the feature and their pure information. So, you are looping over everything and transforming them into a feature set and the label. Now, you can see the feature set and the labels are being identified here, and we are also identifying the length of them, that is being given here. Now, since the training takes lot of time for this linear regression, and we are just using the first 10,000 entries, we are not taking the complete thing for the demo purpose. So, also the truncated features are also being given here. Okay. So, this is the output of this particular thing. For example, when you take the word like Perry, is the first word? Yes. It's a last word? No. Is it capitalized? Yes. Is all caps? No. So, all these features are being identified from the word here. Now, what we are doing is we are converting these features and the label into vectors and converting into the train and the test data. So, vectorization is the process that is happening here. We are converting them into the format. So, now again we are splitting them into the training and testing. Now, once this is done, we have to now start training the data. Now, for the training the data, we are using the logistic regression as a kind of method, which we are again using it from the libraries. So, again we are fitting it with our training the data, and we are predicting it, and you could see the accuracy for 10,000 sentences. Using 10,000 sentences, we have identified the model, and this model predicts 93% accuracy for the given test data, and also the classification of each of the categories. Labels, their precision and recall are being given here. Okay. So, similarly, we can run the same thing using KNN library. So, again we are like importing the KNN neighbor classifier from the sklearn neighbors. So, we can also do this implementation from the beginning, but right now I am using some kind of libraries and calling upon that particular method, and we are initializing the train and getting the k nearest neighbors, and again we are fitting it with the same training and the data set that we have just created for linear regression. So, now once we are predicting that one and running the prediction, you could also see the accuracy by the KNN is 0.88, because here we do not need the labeled data. So, we have to actually give in the training data, though it is an unsupervised. So, we are using it as a kind of supervised method. So, we are giving the whole tags, and also we are giving the actually classification report. You could see the reports of each one of them here. So, when you are actually running it with your data set, you will see the difference between the logistic regression and k nearest neighbor, and try to classify or try to give the kind of experiments that which experiment actually gives you the best output, that has to come up with different classification method now.